Okay, I guess I should introduce this person. Like, you might have to squint to see him. He's a little yeah, his name is Meg. He spent too much time in SolidWorks, and he's mental support. All right,
SolidWorks.
anyway.
Everyone knows SolidWorks. You guys better all have SolidWorks downloaded, right?
Yeah.
Yeah. So what's SolidWorks? SolidWorks is a 3D CAD software, right? That's about it, honestly. I don't know. Simulate stuff, yeah, just make stuff in the computer.
So CAD software.
Yeah. There's there's two main groups we're gonna be using. There's the part file, and assembly file. We're probably not gonna use the drawing file, but there's something you should know that exists. So where did my title? What? Oh, it's different. So this, when you open SolidWorks for the first time, open the SolidWorks parts file for the first time. This is what you normally see, right? You have the sidebar, you have the top bar, and you have the right side, which I don't actually even know what's for. It's literally just the 3D experience thing, which is actually a scam. Anyways, so SolidWorks. What is this? Is it bugged? I don't know. It looks different. Anyways,
What do you mean it is different?
your screen is bugged.
No, that's bugged. Yeah, that's bugged.
Is the recording bugged though?
I have no idea. Wait,
Oh, that'll be fun. Okay.
what is this supposed to look like? What the fuck?
And I'm looking. I'm like, this isn't my slide. Like, I don't really remember, but like.
That is, I don't know what's happening, but okay, now it's.
Alright, so the two main bars you should know are the top and side bar. Top bar has all the tools, right? All the funny things you could do to things. The sidebar has different sections, properties. So, first one, you know this. The main one has the actions you've done and like the part itself, right? Second one, properties. You could properties are where you can add variables. Actually, I would never use them. Is funky. Third one, configurations. Let's say you have a part that has 3 different variations, right? You could use a configuration to set. So you can just have one part file with 3 different configurations, so you don't have to make 3 different files for this, practically the same thing. So for instance, you have this thing, right? But you have one that's this long, and this long, right? You could, instead of having 3 different files, 3 different part files, you can have one part file, each specifying the length of it, so it saves on space pretty much. Fourth and fifth one, never used before. So top toolbar explained, yay. So okay. Oh my lord!
God,
holy! Now it's even more glitchy. Anyways,
Jesus. Okay, no, I need to make sure the recording isn't bad. So. What's happening?
Yeah, so look at that.
It's almost like we can't use.
So okay. Features. So very useful. Very useful. A bit more niche, but still pretty useful. Pretty niche, right? So okay. Extrude, revolve, you know, right? Sweep, lock, boundary. I don't really use that. Extrude, cut. The extrude, cut, and the extrudes are practically the same thing, but just one's adding, one's removing. The fillet, linear, pattern, you know what those are. Shell, pretty much, if you have an object, like a giant cube, you could shell it and select the faces that you don't want. You want to be open, and it'll create a hollow inside for you, right? So instead of having to model each wall, you can just make a giant box and just shell it. Draft, rib. Rib is pretty useful. Wrap, intersection, and mirror, right? The rest, don't use this. Don't ever use flex. I do it for fun, but the problem with flex is, okay, so the tool itself is cool, but it's just you don't really have any dimensions to build off of it, because when you're building with SolidWorks, you want everything to be fully defined. But with flex is that it's really hard to get it to be consistent, right? So if you do the same flex if you have a part and do a flex feature once and do it again, it could be different. So don't use it unless you want to do really funny things. Click. Thank you. Sketches. So there's actually a down arrow for 3D sketches. Have you guys ever used 3D sketches?
I've tried.
Mentally insane. Don't do it. 3D sketches are only really good if you're gonna play around with planes. So I have done 3D sketches, but don't. We're not going to use it here. Smart dimension. Your child. Use it. Exploit the child. Okay. I should say that. Use it a lot. Okay.
Child labor.
You want every single line to be fully constrained. Okay. You know this. If you guys don't know this, you know this, right?
Yeah.
Yeah, right. You can draw a line, a circle.
Points to the only year 3 student.
line.
You know this, right?
Just in case, right? Just in case, you know this, right? You better. Spline, right angle, arc. Actually,
We
right?
need to give you a gun, so however you want.
Actually,
Just throw at the person you don't like. I have enough guns.
gave it. Why do you have a Nerf gun? Give me the Nerf gun.
For legal purposes, this is a safe space.
Actually, true. Okay,
Guys, have a
these
food bag?
are use less. Trim entity is very useful. One keynote in trim entities. You know how sometimes it deletes your dimensions, right? There's an option to convert.
I need to like record this, and then it's just out the end. Right?
No.
Good. Okay, we're gonna do a group activity too. Okay, guys. So trim entity. There's a really useful feature on the side in which you can select turn trimmed entities into construction lines, and that will preserve your dimensions. So just a quick note. Very useful. I found it out the hard way. Convert to entities. Offset is useful if you have like multitude of similar features scaled down. Offset's useful. Mirror, linear sketch, move entities. One important note is that let's say hypothetically, you're in the feature section, right? And you extrude cut a hole, and you want to make multiple of them, right? It's better to do extrude cut in a sketch. No, it's better to do like multiple holes in a sketch than do multiple features, because it's actually more laggy for the system. Okay, so I'll demonstrate on the computer later, right? But just quick note, remember that. Meh. I'll split entities, line, surface stuff next. I love surface. I know. I hate loose surfaces. It's such a pain. Okay. Extrude surface extends the surface out. Revolve surface revolves the line around their axis to create a surface. Swept surface, loft surface, boundary surface, funny stuff. Pretty much, you just modify surfaces, right? By the way, surfaces are not actual bodies. So the difference, you guys know the difference between a body and a surface, right? A body is in a closed space that SolidWorks has specified as a body, right? So, did you raise your hand?
No.
Oh, okay.
Okay, no. Think of it like this. A surface is like a piece of paper.
Okay, go ahead. Yeah, go ahead. Oh, yeah, go
A
ahead.
surface is like a piece of paper, right? You can't like effectively it has 0 volume, so that's why it's not a body. Now, if you make the surface into like a paper box, that is considered a body because it is
Incorrect.
because
Fucking
what
incorrect.
happens is
Nuh-uh.
SolidWorks puts like the
They
entire
don't,
thing
they
as
don't,
like
they
a
don't.
paper.
They actually
They
don't.
actually don't.
No, they don't.
Why do they
You
not
gotta,
do
you
that?
gotta do knit surface and you gotta what's it? There's just some other stuff you gotta do. Yeah,
That's
you're wrong.
kinda
Get
cringe.
destroyed. I found that the hard way. It isn't. Anyways, now you know why I said don't mess with surfaces. Because it isn't. You literally have to, you gotta do the thickening. Pretty much. I believe you gotta thicken it.
So you make the paper thicker.
Yeah, you literally just,
So you're just extruding the paper.
literally, yeah.
Welcome
Extruding
to
it.
surfaces.
That's
That makes
surface.
it funny.
Now you guys know my
That's
pain
so
is up.
funny.
I know, but it's like, imagine going from Python to C++. I don't know if that analogy works. It's like
Yeah.
more precise. You can do more funky stuff with it, but you gotta do more funky stuff to get it to work, right?
Yeah.
It's more like Python to C.
Yes. Actually,
There's no bullying anymore.
for real. Anyways, knit surface combines the surface. So like, let's say you have multiple different surfaces. You can combine them into one, so that allows you to do the actual fixing stuff more effectively. I'm rambling on. Go ahead, continue.
Huh? Oh.
I actually don't really use this. I don't really use sheet metal because I don't make stuff in real life. I make everything in SolidWorks.
Well, now you gotta
this
start using
is- This is more for you guys know what sheet metal is, right?
Yeah, yes.
So you get a
Sheet of
piece of metal and you bend it into like the shape, right?
Paper metal.
This is literally just paper metal, right?
Yeah.
But
yeah, effectively.
it's kind of useless if you're just making something on the computer. Because you're not actually making it in real life, so what's the point of that?
You don't care about the price.
Yeah, right? Also, we're probably not going to be using this because
We don't have the machine.
we don't have the machine, and also it's not very precise.
Yeah.
Right? Direct editing, this is like you're in assembly now. You're literally saying,
assembly.
hey, I want to delete this one face of a body. I want to convert that into a bunch of surfaces.
Okay, imagine
Funky
you're
stuff like
working in C++ and then you go like you open up a terminal, you pull out directly into the address, and then you start changing
Yeah,
stuff.
funny
This is what
stuff.
this is.
Ah.
So don't do this. Don't work with this until you're very, very
Actually,
confident.
okay, no.
And you'll still fuck it up.
Actually, no. Okay, one quick suggestion. Do play around it. Don't listen to him. Play around with SolidWorks. Try funky stuff. Okay, see how SolidWorks see how it works, right? Because you never know until you try, right?
But if you use this on an actual part, I will kill you.
I will make sure to be using it. Evaluations. I don't really use it. Okay, so Edison uses it a lot more. He uses the measure tool a lot, right? You want to explain why?
So the measure tools work in this way. So how whatever you want. Okay. So let's say I want to measure the distance between like the Okay, let me find something. Is there a
This
phone?
water
Okay,
bottle.
phone.
Oh,
okay,
shit, okay.
yes. Whose phone is this?
It's yours now.
Oh, okay. Okay. So I want to find the distance between, like, let's say this point and this point, right? Normally, like, if you're in an assembly and this is the part. Okay. You will have to like put a sketch on the screen, right? And then like just pull like a line over here and then measure its distance.
Yeah.
But what I can do is I can like if I have the measuring tool open, or like not even if I don't have it open, I select this point, control select this point, press the measuring tool button. Automatically tells you how long it is. It also tells you how long it is along the X, Y, and Z direction, which can be very useful.
Imagine it as like a measuring tape. Right?
Measuring tape, but you can just like
measuring tape, but
should I just show them?
not in real life. Yeah.
Yeah. So
Why does this gun not work?
icons literally measuring tape.
Yeah, I know.
So,
another very important tip while he's
what
pulling
the
it up. Another important tip: if you ever don't know what a thing does, look at the icon.
Yeah, it just tells.
Yeah.
Yeah.
Say like.
Okay, so
Whoa, what is that?
let's say I want the distance between here and
For
over
audio listeners, it's a
here.
Nerf gun.
Right? 2 points.
Actually.
I press evaluate measure, and it tells you everything that you want to know.
Wow, look how well I made it. It's exactly.
Why are you like that?
Look how well made I made it. Alright.
Okay,
so-
yeah, so that's measuring tool. You can also do two surfaces if you want to. And you can also do lines, everything that you can think of. Like even if you want to do a length.
I should
Okay.
really send a.
Select the thing.
I don't have pictures. Wait, no. Kate,
There's
do you
nothing.
still have the zebra pictures I sent you?
What is zebra
The
pictures?
zebra stripes and curvature. These are the two things I like using. Because I use planes. So have you seen these before?
No.
Okay, so pretty much what curvature measures the amount of bend it has, right? So yeah,
It has no bend.
look how no, it actually doesn't bend. You can see how it warps down a bit.
Oh, it
Anyways,
does? Oh, wait, yeah.
right. So because this is another reason why flex is not good. This is meant to be flat. But you can see how it's kind of bent in, right?
Because you flexed it.
These are all meant to be straight. See how these are straight, right? This is wonk. Because it's most likely because of the flex feature twisting it back, but because it's a bit imprecise, it does weird things. No reason
Welcome
not
to
to use
hell.
flex. Zebra stripes shows you the angles more clearly. So it makes let's say just a 1 degree angle. It makes it a lot more obvious because you're gonna see the stripes at a different angle. Right? But it's a different angle here, right? So those are probably not gonna be useful, but it's really cool to know. Okay,
Okay, go back. Okay.
back to the thing. Why is it Chinese? Anyways, yeah. So we're gonna use this more with assemblies because with a part, there's only a certain amount of things you can do, right? Next,
Oh, God.
fun stuff. We're gonna get to you later. Next.
It glitched out 1 second. Yep. Okay.
So tips and tricks to making a part and assembly in SolidWorks. So these are some of the tips I put together. So first of all, start with a sketch of what you want to make, right? Unless you're really proficient in SolidWorks, drawing something in real life is gonna be a lot easier than making it in SolidWorks, right? Because a simple shape
Bottle.
this bottle, it's not that bad. You could draw a very crude bottle shape, right? And you can be like, okay, you want this to be 40 millimeters. You want this to be 110 millimeters, right? Really easy. But making this in SolidWorks is going to require a couple more steps. Actually, not really. It's only like 2 steps. But like, you know what I mean, right? But it's like I even sketch the things that you'll see later. I'll sketch them first, and then I'll make them in SolidWorks to get the dimensions down, right? So that's a suggestion. Also, 2, actually start. Don't be like, oh, I'll do it later, guys, right?
Me for real.
Me, actually, bro.
Oh yeah, he started writing those slides like yesterday evening. So
Yeah, no, that sounds like my
Yeah, the
university
week.
career so far.
yeah, it's like
Had a week. Yeah, I did have a week.
Actually, no, he gave you like
I know. Right?
I actually gave you like
He
last
gave me a
week at the same
and
time.
I only opened SolidWorks yesterday. Too.
So
Let's continue. I got burnt out. So
Yeah.
that's fair. Yeah.
so when starting a model, this is a tip from Edison. Either start with a individual part. So don't start with an assembly. Start with a parts file, or build around an official set file. So like there's official files of the like parts we buy, right? So you can find them online,
Oh,
like
wow.
a motor, right, or like a wheel, and you build around it in an assembly. So those are the 2 ways. I always start with part. He does it with assembly. Hey, come on, shut up. Also, last thing, make sure you're building in consideration of the method you want it to be manufactured.
Sure.
So let's say you have this water bottle, right? And you have it hollow inside, right? This isn't that bad to 3D print, but good like CNCing this.
Yeah, that's not.
Right? So you gotta redesign it,
It's
make
like
it.
separate.
Yeah, so if you want to make it CNCable, gotta redesign it to make it so it's a lot easier for them to CNC.
Yeah,
right?
you like cut it into 2 parts.
Yeah,
and,
like you cut it like right down here, right? Or something
Yeah.
I don't know.
No, in the middle.
Like this?
Yeah, and then you
But
flip
it
it.
curves back.
No, you like flip it and then you machine it.
Oh, sure, you're
Yeah,
right.
right.
Actually, here comes this is the second part. If you are planning on manufacturing a part in a specific way, but you don't know how the frick it works, ask someone. Don't ask me. I'm actually really dumb. Okay, I don't know.
I know how to do CNC, but and 3D printing. But if we want to do it any
Ask
other
him.
way, you're kind of out of luck
Good
because we
luck.
don't have those machines.
If you want to just hammer a piece of metal into a shape, ask him.
Me, yeah,
Yeah,
I can do
yeah,
that.
yeah. He knows how to
My
hammer
job.
stuff.
Hammer, everything else. Actually, okay, let's see.
Anything else, Google it.
So, okay, now, which ones, why is this design good and this design bad? Okay, we're gonna think about this really quickly. Other than the fact that it says good and bad design. Okay, okay,
Well, that one is a lot more complicated geometry.
okay.
There's a horizontal hole.
That's not good. And that one is just fairly simple to do.
So
Okay.
while the right is designed by a 6-year-old.
Anyway, this is a trick question. Click. This is a trick question because you can't actually tell. The reason why the second one is bad is because this one isn't fully dimensioned.
Oh,
fully,
crap.
right? I know. I troll.
That's
How
that
else
is
am I
actually
to show
trolling.
that? It's obvious,
Can't show
right?
it.
like,
So-
oh, yeah.
Right? So you guys know why you want to fully dimension something, right?
Yeah, obviously.
It's because if you shift it, it could
Fuck up your
it will mess something up. And if you make a part big enough, it gets really bad. And it gets even worse if you're referencing different parts in the assembly. Cross-referencing, right?
All right. Do you want to continue?
Yeah,
Like,
really
without
quick.
food.
I still have a little bit more.
Alright.
Though, you can make dynamic hoses. Anyways, what is... Can anyone identify why this one's all blue? Innocent, don't say anything.
Yeah.
Those lines are not defined.
Huh? Which lines?
All the lines
That
are
one.
defined.
Yeah, I know, but why are they blue?
Because there's no length in them.
Yes. It's not constrained to the origin.
Yeah.
There we go. Yeah.
Because
God,
it's an
that was
anchor
my first lab, bro. I was like, why is it still blue?
Yeah, it's actually- I found it out the hard way.
you know what I mean, right?
Yeah, right? Like, you can
Because
put,
like, every line is straight.
Yeah.
If you just make this the anchor point, right? It'll work out.
technically,
Don't
you can
always-
just also put like a fixed point.
Yeah, that's what
Yeah,
I
it's a-
thought.
Yeah. What's wrong?
Yeah, like I know it's a bad way, but like
Don't do that.
people
Don't
will
do
start doing that.
Don't.
So
Don't spread lies. Anyways, next one.
all right,
But that's really how I survived through all my life. I just anchor point down.
God.
I can play all the time.
True.
Oh, I actually survived all the labs without like fully
Yeah,
constraining
valid.
anything.
They didn't even care about it.
You don't care.
They don't care
Yeah,
about.
they don't
I
care.
specifically set out to not constrain, like
Actually,
fully constrain
for real.
anything.
Really?
Back.
Okay, now here
It's
is
hilarious.
a second part, and then after explain why there's a difference between the two. I'll do some live examples, and I'll get you guys to contribute, and whoever gets it wrong, I'll shoot. Anyways, so these two bottles are practically the same. So this is a bottle I have on my desk, right? They weigh the same, right? So in the evaluation, you get the weight of each part with the material that you specify. So they weigh the same. They look the same, right? Look the same. And so pretty much in terms of functionality, they're practically the same. So if you 3D print either one of these, you're gonna get the same result. So in terms of modeling in SolidWorks, one is vastly superior than the other. And anyone can guess the reason why?
Oh,
Sure, I'll take that as an answer. Go ahead, next one.
Alright.
So one of them is a simple revolve, and one of them is done with surface lofts.
oh,
Right? Right? Yeah. So this one, I drew this, right? I drew the outline, dimensioned it, right? And then I just
rotate it.
Rotate.
No, I did the extend thing. I forgot what it's called already.
Funky lucky.
No, offset. Yeah, you offset it. So draw a second offset to get the thickness, and then you revolve. That's it.
Yeah.
One command. This one, 1, 2, 3, 4, 5, 6, 7 planes.
Nah, that's
Each one with a different circle, and you surface loft to each one. Make sure to loft the. Make sure to create a surface at the bottom. Knit them all together, and then thicken it. Which one's easier? This one took like 30 minutes. This one took like 2. So now,
what you do.
the clear lesson in this is just because you can do something doesn't mean you should. Okay, like especially once you get more proficient in SolidWorks, you can do some really funky things like I was showing earlier. You saw it, right? You can do some dumb things to accomplish easy tasks, but sometimes be considerate of the guy you send it to, because like they're gonna have to read your file and they're gonna have to build upon it. And do you want to build upon this, or you want to build upon this? Alright, like let's say you want to modify the diameter of one of these.
Kill me.
How do you do that?
I'll have to
Ah.
manufacture it
Actually,
as well. So.
Yeah, right. Literally. So you gotta take that into consideration. Okay, pull up SolidWorks. We're gonna start modeling some things, guys. So first
Let's see
of all,
how many people get
this is
shot.
a simple shape, right, guys?
Modeling that.
No, not that. Thank God. You guys wanna? No, we're not.
Vastly increase the chance that you're getting shot.
So okay, actually, so we're gonna model this. How should we start?
Square.
Rectangle.
Okay. Not bad.
Measure the physical piece.
Okay, what plane?
Top.
Plane. Right.
It doesn't matter.
Okay, realistically, it doesn't matter. Honestly, I was gonna pick right. Anyways, rectangle. Let me just draw a quick rectangle. Easy rectangle, right? Dimension. God, why are you so weird? Why do you have this?
Yes.
What the fuck is
Why not just make
12 and a half. Honestly, what?
12 and a
Make
half.
up the dimension.
Honestly, this is gonna be 12.5 millimeters.
It's supposed to be inches. We got 12 and a half inches. but
Measure the other
millimeters
side.
is good enough. Okay, this one, the 2.5 millimeters.
2.5. Okay, now what?
Now we make a hole.
Make one hole? Okay.
One hole.
So let's. Ew, cringe. Okay, let's make a hole. Measure, please.
What?
Measure. Measure the big hole.
You already committed this part.
You like the
You know, this is literally one lesson I needed to teach for this one shape. God, this is poor
like-
Edison.
The funny thing is, I remember like. The
Okay,
last
so we're getting
Quarter of an inch.
Yeah.
design.
no, it's not quarter.
Uh-huh.
They're
Just like
I had to use
is it?
the linear sketch
Huh?
pattern.
Oh
I
yeah,
had to
yeah,
figure that shit
no,
out.
it's
Like,
like
what the
okay,
fuck
this is
and then I
8,
was, like,
right?
figure it out.
Linear
But
sketch.
actually-
Oh yeah, true.
3/16 of an inch.
We did we? Yeah, I think so, right? Are you guys okay?
3/16 of an inch.
Turn that into a decimal. Oh, shit, you're right. You know what? We're gonna make that up, okay, guys?
Can you just type in 3 divided by 16?
Yeah, I can actually.
Yeah, you can.
You're right. I forgot. Yeah, you're right.
Yeah.
Which one's
but
divide?
your solves are not that hard.
1.875.
Wait.
3 divided by 16. Okay, now.
Now we
You
can-
don't even use equate, bro.
Yeah, you
just equate the two
You're not even equating L.
Yeah, no, I'm too lazy.
That's fair.
I'm too lazy. So now what?
Now, how far is away from the wall?
We're done.
We're done? Okay, so we're gonna go features. Okay, we're done. We're done, boys. Wait, you have this in it. Edison's gonna murder you. Actually. Okay, what next, boys?
1/8.
1/8?
It's 1/8 from the sides.
Okay, gotcha. Yeah. You know, I never actually used the equate function.
L.
Wait,
I know. I never use it. I just did this. One
Do more work.
divide by. Exactly. Damn right. How'd you know? One over 8.
Oh,
There we go.
good.
Now what?
Now we'll do linear sketch. Now we made it small.
There we go. Yes. I'm surprised you guys didn't do the funny thing,
What?
which is
Strangely,
extrude this first and then do a separate extrude cut.
that's
No,
what I
fuck
do.
that. Oh, that's like you told me. What do you mean?
No.
You told me to do that.
I am telling you guys not to do that now.
You told me to do that one.
Sucks to suck. Have you tried getting good? Okay, so let's go.
Almost did everything.
Yeah, okay, you know what? You guys already know how this works, right? You specify like 100. Let's do. What's 0. 0.28. Thank you. 2 over 8. Probably 2.
2 over 8 is 1/4 for 0.2.
Oh shit! Wait. Wait. What? What's this?
316?
1/4?
It should be 1/4. Yeah, it's 1/4.
That's very small. I ain't gonna lie. You sure?
Because that's inches, and then you
No, because
millimeters. They just straight convert it to. So they straight
Yeah,
no,
just
hey,
the
Am
whole
I
thing-
done?
it's on the left side to left side.
Oh, I'm actually so stupid. Okay. Let's see if this is possible. 1 over 4 plus.
0.19.
That's half a millimeter or half an inch. 0.5. 0.5. So just 0.5. No, it's not really you.
Shit. No, I don't know how your keyboard works. There you go. 0.5, right?
There you go.
And then you also the quick trick. Don't select the whole thing after and then do the linear pattern down. You can just do the
How
y-axis.
many holes did you? What?
What? Oh yeah.
100.
Hey, I'm not risking it. Okay.
25 holes.
Let's do 30.
It's 25.
How'd you guys know?
Because it's a
25 bars.
official
25
size.
Oh, is it? Oh, I've
Yeah.
never used Vex. Okay.
It's 5
Anyways,
down.
let's do 1 and 5 down. Okay. What the fuck? I forgot. 0.5.
You didn't select it.
Son of a bitch.
Every hole is a half inch for Vex.
There you go. So you do this, right? Click check. So Edison. Anyways, we're not gonna do tiny holes. You guys already know.
The
how to
tiny
do that.
holes are exactly the same. It's
Exactly the
just
same. You guys know how to do that, right?
And also, you can technically find this
And then-
cat model for this online. So
Whoa, that's one thick. Wait, that's one thick. Anyways, okay, you guys get how this. So, keynote from this is instead of. It's better to do everything in a sketch and then extrude it in like one at like by itself than to extrude and then cut a bunch of holes. Right?
unless if you have a good reason for it.
Yes, unless like it's your last resort or you're like lazy.
No, like okay, what I'm thinking is like if you need to later on adjust
Yeah.
those holes, then like you might as well.
Then yeah, that is true. Yeah, so as long as you have a reason, you can do it that way. But generally, you want to do it this way because it's less work on your computer.
Yeah.
Because I don't know if you guys have gotten to the point in which you like kill your computer with SolidWorks. Yeah, you guys know, right? So just be careful. That way is a better way overall. Okay.
Okay, this is like one. Okay, if you do this is in 2 steps, it's 2 steps, right? Now it will become a problem when you're in RoboMaster and you have like upwards of 500 part assemblies and assemblies of assemblies.
Yeah, that's.
I've done that already. It's funny.
Like
Anyways,
the
okay.
chassis is like 300 already.
Yummies. Anyways, okay. You guys get that, right? Honestly, I think you guys already know how to model this then, right? It's revolve, right? Get the profile, revolve it, and you can just make that top part, right? Honestly, very chill. Okay, let's go back to your lesson. We don't need to do any more real life examples. Oh, what?
Skill
Is your popcorn done?
Okay, you're free to go then.
Holy, wait, what?
Should we
Yeah,
show the
just finish
screen
it.
what the part actually was?
What?
What the part actually was?
What do you mean? What the part actually was?
The screen can't see the part.
No, it can.
Are you video?
No, it's just capturing
Yeah,
web.
but you didn't see the actual part that we were holding.
Turn the camera.
It's fine. It's fine. I don't have a camera.
No, you just search up on Google.
That doesn't even shoot, man.
I got 100 of these bullets for $2.
Oh Jesus. Okay, you know what?
Okay,
Never-
that's
Okay. All right, continue. End of the drawing, right? So once again, don't make it needlessly complicated. Be considerate. It'll be funny if you do that to Edison. I know what I'm just saying.
Shut it.
It'll be pretty funny. Also, another thing you guys should probably try playing around with: SolidWorks Visualize.
Kinda cool.
So it's like Blender, but just like
Blender,
But
but
better.
for SolidWorks.
It's so weird.
It's cool though.
It's
Like,
so-
even it's, like look at this glass.
Yeah, it looks good, but I mean, like, I don't even.
This is rendered in 8K actually.
My computer's like gonna burst.
It is ray trace. Actually,
I have
yeah.
integrated graphics. I'm like, my computer's gonna die.
Bad.
Bad.
So how long did it take you to render that?
The thing is, I was running like 2 games in the background, so that was around like
It has a 4090. That doesn't
30,
matter.
90,
You have
30,
30.
39.
Yeah.
Okay, I was like,
No, not the point. I'm not that rich. I'm not that rich. No. I'm not that rich.
Let's go.
Anyways,
Go.
like, next. So okay, flex tool. Don't use the flex tool. You can do stuff like this,
ew.
right?
It's like,
But it looks cool, right?
Yeah.
But also-
okay.
right?
Another important note, you can see how like it's not aligned here.
Yeah.
It's because of the flex tool, right? Another reason, hey, don't use the flex tool because it's really hard to get it to line up, right? So pretty much, have fun with it. Don't use it for the robot. Okay, gun features. Hole wizard, useful. Use it. It is something to make things your life easier. Now, the one tip I have you guys all used Hole Wizard before?
Like once.
Yeah.
Yes.
Once, maybe.
Yeah. So
I don't like it.
yeah. Okay, I don't really like it either. But it's a useful thing to know. Hole Wizard's right here, right? You click it, but before you do that, locate the points in which you want the host to be located in. So in the sketch, you can make a new sketch and use the point thing, right?
Mm.
And put points on the surface where you want the holes to be located, right? And because like, huh? Yeah, the center of the screw, right? So the reason for this is because if I recall in class, so many people were suffering with trying to get their screws to be located in the right locations, right? Because it'll always be off by like a tiny bit because it won't snap.
Mhm.
But with this, the screws will literally just snap to these, right?
Yeah.
So it makes it a lot easier. Once again, you can just specify type of screw, yada yada yada, and then it creates holes. The one benefit of this is also there's also a tapered bottom, so it's a bit more realistic.
Yeah. So like, if you want to do like a flat like sunk head screws,
Mhm.
or like the
There's
screws
all
that go
kinds
like.
of- and,
Yeah, there's a parameter built in, so you don't have to like manually like
Create like each sketch.
yeah, which is really
You don't have to like make a new surface, make a new plane.
It's in like the properties tab, right? Where you can like.
Yeah, on the left side.
Yeah.
Everything important is on the left side, except for simulations, which sometimes you have a guide on the right side. And also the bottom sometimes useful. Left side. Go ahead, continue.
all right.
Move it to the wherever you want.
Don't.
Shush.
So simulations, yay! Am I right?
Funny.
So I did all this yesterday. So there's multiple ways of testing your objects, right? The most simple one is just to make it and like, right? Right? But the thing is, some of us don't have 3D printers, so it's a little harder. So the second best option is to do a simulation in SolidWorks. So there's a lot of things you can do. You can do fluid sim. You can do motion sim, right? So pretty much how the object interacts with other parts in an assembly. So like how gears will interact and stuff like that. How the object interacts with the fluid around. So it can be pressurized. It can be like a fan. It can be stuff like that, right? It can be different fluids too. It's actually very complex. But right now, because it's a part, the only really useful thing is the stress test.
Yep.
Right? So
Oh wait.
we're gonna use this part. What the fuck?
No, it was
Okay.
glitching out.
Can you guys identify how this part was made? This was made pretty easily, by the way.
Yeah.
You have a cylinder,
Yeah.
you extrude, you draw this, you extrude that, and you're done. Yeah? Easy, right? So, okay, so we're gonna start. Have you guys ever done a stress test? No?
Yeah.
You've done it. Okay, yeah. So, okay, we're gonna have to go through everything. Right, okay, go ahead. So, first,
Oh. Okay.
we're gonna, when you open the, where is it? Simulations tab, right? On the top, there's a start simulation. What was it? Wait, go back. Go to that. I forgot how it looked again. More. No, go all the way back to like the simulations top bar.
What do you mean simulation? I might as well just find it in SolidWorks.
Yeah, just find the SolidWorks, man. I don't know. Simulations. New study, right? So you click on new studies. Go ahead. Well, let's go through it with you. Actually, like, for simulate what's that?
Wheel.
Right.
It's gonna break.
Actually, okay, so you can do static, frequency. So static is just like, right? Frequency is like oscillation. Topology and design. Topology is funny because it does like the, like that
Yeah.
funny thing. I have an image
The
later on
funny.
of that. These are more fancy. Drop test is funny because you can drop stuff. Pressure vessel design is pressure, but it's not fluid sim. Anyways, we're gonna go static. Click static. Click the check mark. Have you done the simulation?
Yes.
Good. Why is your
Oh,
thing so
boy.
slow? So,
Because
welcome to the simulations tab.
Welcome to hell.
First of all, what's really useful is this top bar because it outlines what you have to specify. Right. So, first of all, apply material.
You want me to make it out of aluminum?
Make it of
Plastic.
gold.
Out of gold.
Yeah, there's gold. Apply. There we go.
I should close it, right?
Okay, before we close, one quick note. Well, is that elastic modulus? Anyways, anyway, some of these don't have the actual information fully filled out, and in that case, you actually can't use the material. And in order to modify, you gotta actually modify the raw files of SolidWorks. So I was like, not doing it. And it's just pick things that are close to the things that you're actually gonna use.
That's no compressor for
Use
yield strength.
actual, like what's actually gonna be made out of. I'm using gold because it's funny, but use things actually made out of it, right? Click apply, not close.
I might have clicked
You
it too many
idiot.
times. Oh, yeah, now it's gold now.
Yeah, so now you see
Poop brown.
shiny. Now, first of all, you have the material now. What else do you need in a system? Come on. Oh, what's it?
Forces.
221. Okay, so you have a forces, and
Moments.
no.
Force.
No. So you have external
Surface.
forces, and you have
reaction forces.
reaction forces. There we go. So let's start with external load.
Oh wow, it's just there.
If
Yep.
I-
Click external loads. Oh shit, how am I gonna do external on this? There's no good surface.
Just add it over
Drop it
here and then like.
No, yeah,
support it.
let's do that. Okay. So where is it? Did you open it? There you go. So you see, there's a force and then there's torque meter,
Yeah.
right? So let's select this surface right here, and just hover, click it, and move your get your mouse out of the way. Shit, frick off. Go here. Now turn the thing, rotate too far, more there. So now you can see how all the arrows are pointing this way. It tells you in the direction in which the force is applied. Right? Yeah. So you have force. The surface you're applying the force on. The direction, so you can either be normal to the surface you're selecting, or it could be like
Yeah, or some other direction.
fancy angle, right? Force, do 100. Okay, well shit.
Oh, okay. Is your computer gonna handle?
No. Check mark.
Oh damn.
Next, you gotta reactionary forces. Go to pictures.
Where is fixtures advisor?
Yep.
Did I just
Fixed
do
geometry.
fixed geometry?
Remember that.
You don't
Fixed
need to
geometry. There's also rollers, there's hinges, just like what was it class called again?
Should I fix it on a roller?
Sure. Sure. Fixture on a roller.
This is stupid.
There's no pivots in this, by the way, because this is a STM file. Everything's just one file.
It's not
So it's literally just a solid piece right
Oh.
now, right?
Okay.
So there's not going to be any fancy rotation.
Yes, there's no assembly. It's not assembly.
This is not
This is a
assembly.
part.
This is literally a part.
This is a part
yeah.
in this
So,
assembly.
you see how this?
Okay.
You can see all three forces, like the XYZ reactionary forces. Just like 221. Oh my god.
That's a lot of forces, but imagine doing that.
Actually. God,
Literally, what's
imagine
gonna be on the next midterm?
that.
This is literally gonna be the next
right there.
picture.
You're like, that's good. There's gonna be a picture of us. Click check mark. Actually, yeah, okay. Check mark. Now, let's look at this. We have studies, bodies and material, interactions, mesh. Go click mesh. No, not that one. You idiot.
Oh, now it's locked up. Hold up.
You dumbass. You idiot. Come on.
Okay, where's mesh?
Not sharing.
Where is it?
Right here, mesh.
Oh yeah.
Why does it look different? Right click. Create mesh. So you guys know what mesh is, right?
Yeah.
Mesh analysis.
Yeah,
Shot.
So what a mesh is, it pretty much changes a part from a SolidWorks file into a bunch of itty-bitty triangles, right?
Oh,
So you can type it's like a bunch of tiny trusses if you want to think about it. I don't know,
I
actually.
want to think about
It's a funny way to think about it, right? Anyways, you can specify the density.
Oh,
Your
yeah,
computer
let's
will
burn our
crash.
computers.
I
My
know.
desktop will crash. Go to mesh quality. So this is just simple. If you want to do a really quick one, simple. Mesh quality, you can specify high and draft, right? Go back to, this is the old version, isn't it?
It's
Yeah, no shit.
2020.
Okay,
Yeah.
okay. Yeah, you can go advanced mesh parameters. You got just how, where you want the detail to be.
What the fuck is
I don't know, man. I honestly don't know. So you can do like curvature based mesh, so like the more it curves, the more precise, right? Blended, yeah, just click check mark. You don't have to
It's
create the
something.
mesh. Just wait.
Oh no.
Just wait. Yeah, so it creates a mesh.
Ah.
Maybe we blended. God, this takes like a second for my.
No,
It's using like 1 gigabyte of mega, like.
No, honestly,
Draft.
as long as you don't go.
Yeah, it's
You're
like
good.
crank the
Yeah,
file
I think I did. Was it?
Is this normal with a fail sign?
No. That's
Oh no.
you really fucked up there, bro. It might be because your triangles are too small. They're too big.
Well, shit.
Okay, the thing is, I remember once I tried doing each triangle as, what was it, 1.3 nanometers? No, my computer froze and just bricked itself for like a
Yeah, no wonder.
Yeah.
I wonder why.
And it was
What
like,
are you doing?
look at that. It's a tank, you know?
How big was it?
It wasn't actually, it was only this big. But it's pretty detailed.
Number of components that failed to mesh 32.
How many wheels are there? Click OK. Let's check.
It's not.
Oh, no. Every single wheel failed to.
I wonder why. It is actually just like a cylinder because it's a step file. It's not a
Yeah.
triangle file.
Yeah, so.
But that makes sense though. Like,
Yeah, it does.
why the wheels fail?
Yeah, oh well, that's funny. I
It's
guess.
like a separate body.
So the forces aren't even attached to it anymore. So
The
let's
screws
check.
also failed, but like
So,
the nut
yeah.
did.
So I guess let's find a new force point. Change the external loads again.
How the hell
Left,
that work?
left side. Come on.
I
I've done this so
forgot.
many times.
I not done this a lot of
Edit.
times.
I know.
Bro, this thing's gonna spin so fast.
Oh, wait.
It's not. No, you're gonna see it.
Oh, bro, this thing's gonna like.
Oh wait, no, this is
How
not,
did
this is the force. This is not the.
Yeah, you want to change the
like
force.
200.
Wait, the force?
Yeah, because it's currently attached to. Actually, no. Let's see what happens. No.
You wanna
Let's go. Let's go run this study.
Let's
Let's go run.
It just
Run it.
attached. Okay, that's
Okay. What's happening? I don't know what's happening.
Well, that was fast.
Rip.
Never mind. Your
Rip.
part sucks at it. Anyways. No, let's go back to the thing. I'll show you something that actually works.
Force.
yeah, there's 200,000.
Isn't it supposed to be like interactions?
Why are you using that? Actually, no. This is pretty useful. This is actually
The advisor kind of works, but I don't
like
know how it
the
works.
simulation advisor. Do you use it actually? Because it actually checks off what you have to do. 10 out of 10 do recommend. What are you trying to do now?
Where's the like the interactions thing?
What is
I forgot.
Huh? What do you mean interactions?
To change the green one, I think it's because of the green one.
That's external forces.
I think it
That's
Actually,
external. No, that's not external.
That's
The
that's
external,
fixed, fixed.
that's low.
That's
Oh, it's fixed. Okay.
yeah. Edit.
Yeah, I'm just gonna change it to this one.
Yeah. Okay. Oh boy. Green.
Wait, it's just gonna not gonna do it.
It will come-
It's gonna press the
Hopefully,
middle.
If this doesn't work, I'll just show the thing.
Oh yeah, because we're dealing with.
All right, do you want to try
It's
it?
hollow.
Yeah,
Try
it's
it.
hollow.
Oh, it's not gonna work.
Oh, rip.
No, it doesn't work. Oh well.
Sad.
Okay, let's go back to my thing. I was demonstrating. The thing is, yeah, that's
Yeah.
sometimes, right? So,
Where is it?
continue. Wait, just
Oh,
stuck
wait,
here, stuck here.
Oh.
Okay. So, once again, apply material, select a material, click apply, next. Apply forces. Make sure it's not 1 newtons. I did that once. Select anchor points, next.
This is how it's supposed to
Mesh.
look.
This is what meshing actually works. solid mesh in process. It's green, not red, right? I did process, right? Don't make it too
Well,
big.
you need to learn how to like read progress, not process. So.
Oh, shit. Okay, shut up. I can't read. I'm an engineer, not English. Okay, let's continue. And now you run the study, right?
What?
And then
One sec.
okay?
No, mine like
Oh.
glitched out. No, mine glitched out to back
Okay,
page.
and
So.
yeah, next.
Okay.
So now, how to view your simulated files. So you have 4 different ones on the side. You have displacement, strain. I don't know what this again. Displacement again. You could click show, and it'll show the bending. So you can go to the next slide, I think.
Yep.
So here, so you have displacement here. So you can see from the original position, this part is displaced the most. And by the way, this isn't a realistic bend.
Yeah, because of the Newton point.
If you look at the units here, this says 1 times 10 to the power of -1 millimeters. So it's literally bending 0.1 millimeter right here. Maximum deviation, right? Once again, a strain. You can see where the strain is. You can see how my design is shit. Bad design, because it's a really weak point right here when the stress is max, right? So yeah, you just right click and click show to show, and then yeah, that's brilliant. But next, yay, we're assemblies now. This one's shorter. I like parts more. Just a quick note: when you create an assembly for the first time, the first part you input in is always going to be fixed, so you can't move it. Every other part you input in is going to be float, which means you can move it, right? But let's say you input like.
Yeah, I've made that mistake before.
Yeah, you input the cap first, right?
Yeah.
And then you input this in. But you want the cap to spin on the bottle, not the bottle to spin on the cap, right? Because that's kind of stupid, ain't gonna lie, right? So, you can right click on the part, change fix to float and float to fix. One very important suggestion, don't fix everything.
I'll fix you onto the ground.
Shit. Don't fix everything, and don't float everything.
Oh, wait, by the way, the one thing I fixed everything was, remember the motor? Like the really...
Oh shit, that
Oh
one.
yeah, that one.
No, it was so fucked that I just said, fuck it.
Honestly,
fix
no,
everything.
that's fair.
That's
Like,
that's
just
hilarious.
don't move.
Actually,
Don't
honestly,
move.
That's hilarious. Yeah.
I get that. That was kind of a
That was so
messed up one. Anyways, next. So, Star Wars Assembly.
One second.
Oh shit.
Glitched out. Oh, yep. Now it
Star Wars
works.
Assembly. So you have did I do all these already? Go next. I don't actually know. I forgot.
Watch it glitch.
Never mind. Go back. Go back. Shit, I did not do it yet. So you know these edit component, insert components, mate. Mate is very useful.
Okay.
Note to self.
Oh, 1 second. I got trolled. It's like, okay, look. It's like the computer's just trolling at this point.
I know.
Bruh.
So edit component. So let's say you have a part that you want to edit in the assembly. You click edit component, or you can right click on the part and click edit component there, right? Linear component pattern. Use that instead of dragging multiple parts.
That's
So
what
let's
did
say,
the motor, yeah.
right? Let's say you have a tank and you have 88 tracks, parts per 88 track parts per track. Don't drag every single one in and like make them by yourself. Just use a linear pattern. Just use this. Use this, okay? Smart fast never use that. Move component. I'll talk about a bit later. Kind of useful. Assembly features.
Well, by the way, move component was how I knew my motor was fucked.
True.
And all like the discs in the motor just like went to Timbuktu.
Now, okay, I guess we're gonna have to talk about mating then, don't we? Layout and sketch are for. You want to talk about?
It does. It does.
It's literally just. You want to make a new
Yeah.
part? Go to insert components, new part. Use these, right? Right? Yeah, right. Yeah. Okay.
Well, in layout,
I don't know. I use.
I feel like no, because layout I think is like assembly.
Yeah, layout's assembly. Actually, no, layout is funny. I searched it up yesterday. It's like a prototyping method in an assembly. So you could draw on a layout, and you could turn each part of the layout into a part, and you could make it from there.
Oh, wow.
Yeah.
That's interesting.
It's cool, but yeah.
But nobody
Anyways,
uses
a
it.
sketch. Evaluate more useful, and simulation funnier. Next, so mates. You guys know what mates are, right? So you have a bottle. Wait, let's say you want to make this lid to this bottle.
First, you made the bottom match the top of the thing, and it'll be kind of fucked. So then
Like
you gotta
this?
do it collinear edge with the.
Collinear.
Yeah.
Okay.
Revolut made it. Revolut mate.
Why? What? Why?
So
What,
we
what,
spin.
what does Revolut mean? Huh?
What is Revolut mean? What?
We're not-
Do you mean concentric?
Yeah, concentric.
What the fuck is Revolut
Why
mean?
does it sound like Revolut?
I've never heard of that.
It's
I
from a
thought-
different.
Technically different, but
different
close
cat
enough.
software. So
No,
they call
different
it.
cat software is a real.
Gaslighting me.
You actually
I
catch
thought you were talking about something like Screw. So you have
Screw
to
is like-
simulate
you got- you
when
can
you
simulate
turn this, that just goes into the threads. Right? So that's a funny thing.
Well,
Another funny thing is you could do, instead of just having it make the bottom of this to the top of this, you can make it so you have distance. So you can have it so you can pull it up and pull it down, but it won't go past. Right? So there's a bunch of mating stuff you can do. Pretty much your goal with mating is to make it function like it will in real life. Right?
Yep.
You don't want this to go through a bottle, right? You don't want this to go
Into the bottle. When you screw.
spin,
Yeah.
right? Just want it to work like normal. So there's a bunch of funky features. The standard is what you're going to use most. Coincident, touch. Parallel. So no matter where you move it, it'll always be parallel, right? Perpendicular. Yeah. Tangent. You have a circle. It's always going to be tangent. If you move it away, it's still going to be tangent, I believe. I think.
You
I'm
can
not
move
sure.
it away?
I
I don't
think you. Wait, can you?
You can't. No. I don't think you can.
No,
It'll be funny if you
No,
could.
you can't. Actually.
I don't think you can. I mean, I haven't used it in a while, bro. It's been
L
like,
plus
it's
ratio
been like
plus
5
imagine that
months
using
now.
basic ones.
Concentric? No. Right?
What
Lock?
do you know?
Don't use lock. Wait, you know what
I
concentric
know.
is.
Screws.
Huh?
You put the screw heads on like the holes, and then it's
Yeah, and
concentric.
it's like concentric. Yeah.
Yeah.
You
You said
know.
you know how to do it, not like.
Oh,
you
okay,
know
no,
it.
like no.
You
If I
know.
know the N-O.
It's one of the most useful things.
Yeah, it's like the
Distance limiter. So you can either specify maximum distance, minimum distance, or both. So
or
you
it
can
is
have it
this
like
close.
instead of like you want to be here and here, right? Or you want to be you don't want to go past here, or you can have it like from minimum here to maximum here. So you can specify all that with that. Angle, limiter, yeah. You can flip the mate alignment. By the way, quick note, instead of using this all the time, just click on the surface of one thing you want to mate to, and shift click on another, and don't move your mouse.
Shift.
The mate
Yeah, I
options are going to show up below.
Yeah, control.
It just shows up after a
shift.
half second. It's control.
I use shift.
Hey, shift.
Well, you use Mac, so
No, I use it on Windows too.
what's wrong with you?
Many things. I use Mac. Next. Mechanical. Less use. Can pretty much makes it so a part just follows a line I draw. It's a bit tedious. Slot, never used. Hinge, just use concentric. Gear is actually kind of cool.
Gears.
You can have two gears, specify the ratio between them, and they'll spin accordingly. Kind of cool. Rack pinion, have a gear rack. Yeah.
Linear gear.
Yeah. No. Screw, the thing I said before, right? In and out. Universal joint, it just prevents, zero reaction force, one reaction.
It's just no moments.
Yeah,
No.
yeah, right. Yeah, whatever.
It's bendy shaft.
Never use this. I've never used that. Anyways, next. So you guys know mates. Now, interference is something that you guys should all know. What is interference? Don't do that. What is interference? Any ideas?
It's like when something collides with something else.
When something intersects with something. So, when something is like, I shouldn't do that. This is actually my mom's. Anyways,
Yeah, your mom.
there, it's intersecting. You don't want this to happen in real life, right? So, how you check for it is there's in the evaluation section, there's an interference detection. So you can run this, and it'll specify, hey, intersection. That's not good, right? And it'll tell you the amount of area that is like in between the two, so you know where the problem is. There's also some attributes, so you can make interfering parts transparent, yada yada yada, right? The only problem with this is that you gotta set everything up, and then you gotta click the check mark, and you gotta wait.
3
right?
years.
Yeah, it takes a while, because it works for itty bitty assemblies with like 3 parts, or like huge assemblies with like 500, right?
Mm.
There's an easier way if you have small itty bitty things. Click. Quick interference check. You can use the move components feature to check for interference. Remember the thing that messed up the motor?
Yeah.
You can use that to check. So, why is it so grainy? Okay, next. I think it's on the next slide. So, use the rotate component, right? Or move, either are fine. I think I haven't actually used move in a while. So, either choose collision detection or physical dynamics. So, if you have really small things, you can use physical dynamics, and what it'll do, it'll simulate actually hitting, and it will actually move it like as such, right? So like if you want to see how two gears mesh, you can do that, right? Do all components, sensitivity, yada yada yada. If you have a bit larger assembly and you just want to see if it actually interacts, use collision detection and have it so that where is it? Where the fuck is it? Pretty much make it so that stop at collision for collision detection. Make it so if it hits something, it'll stop. So you can't go any further. So you know, right? So pretty much that is a pretty useful feature, honestly. So if you guys want to not use the interference detection and wait a minute or so, you can use that instead. Go ahead. Motion study. Why is it so pixelated? We're almost at the end, guys. Okay. Motion study is like a force simulation, but instead it's just how the parts interact with each other, which is why it's in the assembly section. So have you guys seen this before? Yeah. Funny. Okay, next, let's go. So, how is motion study made? At the bottom, there's a motion studies tab. You open it. You have the timeline, the parts and features. You the like motion features. Click this to start simulating. Click this to start and features. Next, we're gonna speed run. It's funny. Anyways, first of all, change this to basic motion because if it's animate, no physics, no, it will be detected, right? And also, before you do that, figure out what's going to interact with what. So, like, if this is ever going to hit with this, you want that to simulate. But if this is never going to hit it, there's no need to calculate the collision between these two, right? So, okay, next. Motion. So there's two main things. There's motion, motor, spring, dampening. Don't know what that is. Collision and gravity, right? The one I used was motor and collision, right? Because gravity, why am I using that? Spring, no. Other ones, no, right? So first of all, motor, you select the surface, and then you can specify a rotation speed, and if you want it to be opposite, you can specify as negative, right? And it'll just spin this at the specified RPM, or you can have it as a function, I believe. I don't remember. The second one I used was collision. You specify the parties that you are expecting to collide. So I'm expecting this to collide with this. So I specify both of those, right? And yeah, so there's a number of contact pairs, just one. Next. And then final, specify the FPS, calculation FPS, and click simulate. Don't click play immediately, because if you don't simulate, it won't actually simulate for you. It'll just knock your anything, I think. Anyways, and then voila, you have that. Next. Okay, final thing. Remember when I said the topology thing? SolidWorks has a built-in feature for that. So, for instance, you can see how is it this one? Yeah, you see how this one. There's a lot of force here, but there's like minimal force here, right? Topology, whatever, can calculate that. It doesn't really need that, so it could cut it off. And this doesn't create a SolidWorks file anymore. If you actually export this, creates an what's this? STM file?
STM?
Yeah, probably. STM file.
It's not STM, is it?
I don't know. I've never actually made one, but like
STL.
this is my first time ever doing it. But you see how like you're reducing them to it doesn't need, right? So you can use this to optimize your parts. Honestly, I don't think we'll need it.
Why does it look so fucky on that side?
This side, because there's no force on this side, so it doesn't need more
So
material.
it just starts chopping
Is
it
like,
off.
is there a way to because that's not?
Yes, there is. Yeah. You can specify the parameters in here. So you could have manufacturing controls, goals and constraints. So I currently have it as mass constraint. Reduce 20% the mass, right? So currently, to reduce most of the mass, just strip that side, right? Of course, you can specify other stuff, right? You can give it a try at home. It'll be fun.
Yeah.
Anyways, next. That should be over. Yeah, okay, anyways. Okay.
Yeah, you did that.
Please.
That's like a finished slide.
Alright, that's it.
Okay.
Okay, so thanks for coming. Like 3 people.
Yeah.
But yeah, next week we will actually start doing stuff.
Shit.
Yeah,
Oh,
this is where it starts getting difficult. So as you may know, Roadmaster rules just dropped this Wednesday at 2 a.m.
Oh, really?
2 a.m. at like 2:13.
I just like look up Robo Master rules.
So it's like okay, it's the Chinese version. So I'm working on it. I'm working on the version of like the English like unofficial translation.
Actually.
Or just learn. It's gonna be so fun.
Yeah, if you want to learn Chinese, I'm not gonna stop you. But like, if you know Chinese, help
know,
me.
like-
No.
But I don't think anyone here does. So
No,
Fuck.
like I know.
I only know how to speak. That's it.
Yes, we can
so
understand.
it's like if I like okay,
We know, Edison. We know your name.
okay, bro.
Oh, whoa.
Been updated.
Wait,
Wait, I got banned from YouTube. I can't
Sorry?
actually use it without-
Vex, Ahmed,
Yeah, I
like,
know.
do you want
I
like
can't use
Ahmed?
my right.
Yeah, so.
Ahmed? Like
What?
Like, do you want to like start doing Vex stuff? Because yeah, okay. Let's start. Start next week. You probably want to like just
Remember that?
yeah.
Dinner time rule of X. You know where that is.
do both.
Remember
Max
what?
and Robo.
So
But both.
Yeah, ideally, we just start doing stuff for both teams next week.
Okay. Cool.
Yeah.
Thank you.
Alright,
You
so,
ready to do solo work?
time to build.
time to build.
Time to figure
Or
out
more like SolidWorks.
Time to figure out how to
Did you
chase up
see
two
that,
LEDs, bro.